Okay, hi class. So I thought it would be cool to give you guys a video instead of reading in class, and this way you guys can be a little more interactive with it, and I can just walk around and see what you're doing. This is just an introduction to light. So I'm going to read it, and you can read along with me. Have you ever thought about what it would be like to live without light? Perhaps you've been on a tour through some famous caverns when the guide turns the light out for a few minutes. Rarely do we ever experience such total darkness. Without light, you can see nothing. So, what is light? Light is a kind of energy called electromagnetic radiation. This form of energy is also used in X rays, microwave ovens, and radios. The electromagnetic radiation that we can see is called visible light. Different sources produce different kinds of light. The sun produces light because it's hot, and this type of light is called incandescence. Other light sources, like fireflies or TVs, are not hot. The kind of light they produce is called luminescence. Fireworks often have a mixture of both incandescent light and luminescent, which is created by special chemicals. An interesting kind of luminescence is trimboluminescence, the light that some materials give off when they break. You can see trimboluminescent light if you take a clear plastic bag full of sugar cubes into a very dark room. Crush the sugar cubes with a rolling pin, and you should see some very small flashes of blue light. Light is the fastest known substance in the universe. It travels at about 186,000 miles per second, which means it only takes 8 minutes to reach Earth from the Sun, 93 million miles away. It takes 1 second for the light reflected off the moon to reach the Earth. This speeding light always travels in a straight line until it encounters a different substance. Observe this by covering the end of a flashlight with aluminum foil. Poke a hole through the foil with a pencil so that only a small beam of light shines through. In a dark room, you can aim this light and shine it on anything you want to. Yes, because light moves in a straight line. Try placing your flashlight on a table and holding a mirror in front of it. What happens to the beam of light? It bounces off the mirror and heads in a different direction. This is called reflection. Every time light hits a new substance, some of it is reflected. In some substances, the amount of reflection is small because the substance is transparent, which means you can see through it. Most of the light goes straight through the substance, and only a little bit is reflected. Other substances let light through, but you cannot see through them. These objects are translucent. Opaque substances are those that do not let light travel through them, so the light is reflected off of the surface. Reflection is only one of the methods that we use to control light. Another one is called refraction. When light is traveling through one substance, such as air, hits another substance, such as the glass of a window, this juncture is called an interface. Refraction occurs when light bends at such an interface. It does this because the light speed and the wavelength change when the light enters the second substance. For example, when light moves from air to glass, its speed decreases 25%. All of this may sound technical, but you've seen refraction at work many times. Have you ever noticed that your legs look strangely bent when you're dangling them in a pool? This is because the light is being refracted when it hits the water. Observe this at home by filling a glass with water and placing a pencil in it. Look at the pencil from above the glass. Were there any changes in its appearance? Try looking at it from the side of the glass and then look from underneath up at the surface of the water. The pencil looks different in the water because of refraction. Light can be transmitted through an object when the object is transparent like a window. Light can reflect off an object. A light ray strikes a smooth surface, such as a mirror, and bounces off. A reflected ray always comes off the surface from a material at an angle equal to the angle at which the incoming ray hit the surface. In physics, you'll hear this called the law of reflection. White light contains all of the colors. A rainbow or prism separates them so we can see this. Why does a green wall look green in the sunshine? A green wall reflects only green light. It absorbs all the other colors. Why does it look different when it's in the shade? In the dark, it can look nearly black because little or no light reflects off it. Light can also scatter off an object. When light strikes a rough surface, incoming light rays reflect all sorts of angles because the surface is uneven. The scattering occurs in many of the objects we encounter every day. The surface of paper is a good example. You can just see how rough it is if you peer at it under a microscope. When light hits paper, the waves are reflected in all directions. Light can also be absorbed by an object. If the object is like a piece of black velvet, not transparent, not smooth, not light in color, why is a black car hotter than a white car in the summer? Remember, light is energy. Heat is another form of energy. A white car reflects all wavelengths of light. Black absorbs all wavelengths of light, absorbing the energy and turning it into heat. Light can be refracted through an object. A ray of light passes from one transparent medium, air let's say, to a second transparent medium, water. When this happens, light changes speed and the light ray bends either towards or away from what we call the normal line, an imaginary straight line that runs perpendicular to the surface of the object. The amount of bending or angle of refraction of the light depends on how much the material slows down the light. Diamonds wouldn't be so glittery if they didn't slow down incoming light much more than, say, water does. Diamonds have a higher index of refraction than water, which is to say that those sparkly, costly light traps slow down light to a greater degree. So often light's behavior is some combination of these actions. Look at a piece of paper that has printing on it. You can see some light go through it, the white area reflects light, and the black print absorbs light. So that is the reading for today. We're going to move on to a game soon.